Hello everyone, this is Team Hi-Fi and our project topic is based on high frequency trading. Meet our team. Our team comprises of Chahat Bindra, Isha Puthige, Kartikeya Bansal, Mehak Kapoor and Mayank Verma. Let's see what exactly are we trying to do. High frequency trading is a method that uses powerful computer programs and algorithms to transact a large number of orders in a fraction of seconds. So if you need to make more profit, you need to have slower execution speeds. Hence, our objectives will be to focus on minimizing the time and suggesting a more optimal output. Let us see what was our methodology. First, we obtained a dataset of Tata Global NSE, then the dataset was pre-processed. We then used 6 machine learning models, that is linear regression, SGD regressor, Bayesian ridge, Lasso-Lars, ARD regression and Thielsen regressor. After this, these ML models, as we can see, were first trained serially, that is one after the other, and the time was noted. And then they were trained parallelly using joblib.parallel and the time was noted. While training in parallel, we conducted another experiment by changing the backends, that was Loky, multiprocessing and threading. Now, after training these machine learning models in parallel, we took the output that we received from these models and put it into 3 functions. The functions being simple average, weighted average and exponential average. In simple average, we take the past 5 days date for all these 6 models, average it, and if the majority of them are greater than the predicted one, we buy or else we sell. The weighted average, it will give lower weightage to the models with less accuracy and higher weightage to ones with the more accuracy. So according to this, even the prediction is given weightage and we obtain a buy or don't buy prediction. Next is exponential average. In this we are also in this, first we incorporate the weighted average, and then secondly we are also, the closer dates are getting more weightage. That means that the 5th day will get a more weightage than the first day, which means that our prediction is further optimized and the results may be further more dependable. In these 3 methods are also first run serially and secondly run parallelly. In parallelly also we are changing the backends and trying with Loky, multiprocessing and threading. Now we further thought that why not apply parallelism within these functions. So these 3 functions, that was simple average, weighted average and exponential, were further parallelized by using parallel for loop for predicting. The library used was PyMP, and then, like we have been doing for everything, we have changed the backends to check which gives the most optimal results. So this basically was our methodology.
The glimpse of our methodology can be found in this flowchart. These experimentations helped us find some key points. First, we were able to drop the training time. It was evident that for multiple use cases, different backends are required. We cannot use the same backend for our all problems. And once we proceed to parallelization on multiple levels, HPC gives us even more fruitful results. Similarly, with more data, the differences are even more significant. Now, let's go to our results and some of the graphs. We trained 6 machine learning models with different backends, achieving the best results using the Loky, which reduced the training time marginally. With limited data and serial internal functions, linear performs best. Even further, with more data, minor efficiency was only observed. This was not what we expected, so we further did our experimentations and moved to parallel internal functions. The difference between linear and parallel grew closer. The timings were not far away, and when we moved to extended data, It gave us fruitful results, with Loki backend outperforming all. Thus, with extended data and internal parallel functions, we saw HPC could be a huge solution for optimizing the time. We saw that training time was reduced from 56 to 50 seconds. Though with limited data, the results are not visible. But as data is extended, the differences are quite significant. And optimization on multiple levels could be a solution to our many existing problems. Concluding, we in our project use 6 different models to emphasize on training time optimization. Consistent experimentation was done with 4 different backends. The results achieved were further passed into 3 different functions for final predictions. And when these functions were parallelly implemented using PyMP, the Loki outperformed all. Our some key takeaways were multi-threading did perform good, but could not be our final solution, as it was bound by the shackles of global interpreter lock in Python. Sequential implementation can be used if data is very limited, which does not mimic the real world, as in real world the data is far more huge. And Loki is the best implementation available, whether it's training or prediction, provided we implement parallelization properly. Thus, this was all about our project. Hope you liked it, and thanks for watching.